So I'm going to go ahead and start. It looks like people are trickling in, but for the sake of time, we'll go ahead and kick things off. This is the Divergent Interoperability Enterprise session, and we've got some great speakers. Only one of them is not a North Carolina State alumni. So we've got some great NC State folks to speak to you today. And my name's Andy Belcher. I'm from NC State. So up first, we've got Ed Shipman. Ed is currently a GIS systems engineer and programmer at NCDOT. Prior to that, he was employed as a GIS programmer for 9 years at the North Carolina Department of Agriculture and Consumer Services. Is that right? All right, good. Working with WebDev, SQL, Esri, Google Earth Enterprise, and other technologies on a wide range of projects. He's currently serving as treasurer for Carolina ERISA and the co-chair for the NC GIS conference poster session. He earned both a BA in archaeology and a Master of Natural Resource from North Carolina State University. So it's all yours, Ed.
Good morning. So I'm going to start, I'm going to do just some really high-level overview of SQL Spatial, some basic concepts, and then I'm going to move into some projects, and then finally conclude with some opportunities that you can take advantage of most likely with what you have. So I started the Master of Natural Resources at State under Hugh Devine, and we did, most of our work was with ESRI software. And my beginnings with learning SQL were through the built-in tools, select by attribute, where you're writing a where clause, and the joins possibilities. They're fairly limiting. You can't modify the select with those tools, and you can only do a very simple rudimentary join. ArcMap only deals with like a one-to-one join. When I started my career at NCDACS, I began working with SQL Server Management Studio and discovered that you could do all kinds of really cool things and deal with data a lot differently. To begin spatial in SQL, I'm not going to really talk about Oracle at all because I have no experience with it, but I wanted to give them credit because I believe that Oracle had spatial objects available first, several years before anybody else did. ESRI purchased a company, Spatial Database Engine, which is still extant. They don't sell ArcSDE as a separate product anymore, but when you work with their database, SDE is still integral in the database schemas. It's still there, even if it's not sold separately. The OGC, which is the Open Geospatial Consortium, put out a spec for a simple feature specification, off of which people have developed direct spatial objects directly in the databases. Microsoft uses that as well as PostGIS, and this is building like native spatial types and functionality directly into the database. Microsoft has implemented OGC methods. Let's see if this works. Yeah, there we go. So these are the methods and the data types that they have available that you can work with directly in Studio or when you're programming. It is a little limited, but my first experience with ArcGIS was with one of the 8 versions, and they had this awesome thing, the Geoprocessing Wizard toolbar. Most of these are duplicated in the toolbox, but there was a fair amount of limitations there. As the product matured, they added more and more functionality to the toolboxes. They added cut and other things. But in this version, those tools weren't available, so you could combine these and get what you needed out of it. So having less functionality in a way enables innovation because you have to work with what you have to solve the problems that you have to deal with. PostGIS is the open source. Let's see. This should. Trying to get, there we go. So PostGIS is the open source module that adds on to Postgres to enable spatial functionality. They have implemented a whole lot more of the OGC specification for functions. I'm not going to even talk about it here today, but they also have raster operability within the database, so you can load rasters and do raster math and calculations directly in the database. It just goes on and on and on. So some basics. The two basic spatial data types are geometry and geography. Geometry is just planar coordinates. These are implemented in both SQL, Microsoft SQL and PostGIS. Geometry is pretty good because it allows you to just use the geometric geometry that you learned when you were in grade school. You don't have to figure out really complex things like you would if you were going to try and do the same things in a geographic coordinate. Another really important thing is the SRID. When you declare a geometry, it's very important to declare your SRID. If you do that, then by the SRID, the Spatial Reference Identifier, the database knows what unit you're using and a lot of other information. You see these, this is fairly similar to when you change a projection in ArcGIS. You'll see on that projection I've chosen there, the state plane for North Carolina. It refers to the authority is the EPSG. The EPSG stands for the European Petroleum Survey Group, correct. Now it's the International Petroleum Survey Group. This allows geographers and geologists around the world to agree on what projections are. And for that, I think everybody can agree it's really important to have common terms. They also talk about for the SRID is also referred to as a WKID, which is a well-known ID. Some useful sites for figuring out what you basically need a number, and I'll show that in just a second when you declare one of these spatial types. The EPSG registry and spatialreference.org will help you a lot with that. Spatialreference.org has also got the query to insert a new SRID into your database. They're all shipped when you install SQL or you install PostGIS. Every single projection may not be in the table where SRIDs are stored for the database. Like I said, from spatialreference.org, they'll list for any projection you want. You can get the projection information in a lot of different formats. A projection file that would work with a shapefile. The last option they have on there is an insert statement, which is written out for you. You can copy it and paste it and execute it, and your SRID will be added to your database. So when you start in your database, you want to know what projection you're looking at. This works in either PostGIS or Microsoft SQL. Select your geometry field, which those of us who've always worked with Esri products, it's almost always called shape. Select shape.stsrid from your database, from your table. This is a DOT table. One thing that's important in working with spatial functions, usually databases, commands, tables, all that is not really case sensitive, but these functions, that STSRID, you have to follow the case. If you do lowercase STSRID, it doesn't know what you're talking about. I don't know why this is, but capitalization does matter in a spatial function. Below, the next two boxes I've got, I'm creating a feature class or a table in the databases. The first one is the PostGIS. Down here, when I declare the geometry field, that multi-line string, Z, in PostGIS, what that means is it's a those can be disconnected lines. You can have one feature that may be one to however many number of lines, and they don't have to touch each other. Z means that it includes 3D. It includes the elevation coordinates. And then 2264 is the projection. It's assigned when you create the geometry field in PostGIS, or you really should. In the SQL version of it, after you create the geometry, you add a check constraint where you add the SRID. Another big difference between PostGIS and Microsoft Spatial is that Z, the elevation coordinate in SQL Server, is an attribute of the point. It's not actually a spatial type. You can't do 3D calculation directly within the database. Where I'm working now at DOT, looking at roads and lines, that third dimension is very important because we need 3D lengths of roads. So a project I got to work on at DOT was looking at gaps in events. These are 4 routes in Durham. They're concurrent routes, and an event for DOT, what that refers to is like how many lanes a road has, and the measure, like from here to here, there's 4 lanes. From here to here, there's 2 lanes. These events should be countywide or statewide. Any route, they should have complete coverage for the entire state. But what you have to look at is what they call route dominance. Only the dominant route will have the events. So all of these routes, for some portion of them, are dominant. But 15501, 15 is the dominant route because they're both the same class. They're both U.S. routes. 15 is a smaller number, so it's the dominant route. From there to this virtual here, you've got US 70, 85, 15501 all together. 85 is the dominant route. From there north, 501 is the dominant route. From there down, 70 is the dominant route. And over here, it's still 85 because interstate is dominant over U.S. route. So it's a really complex model. When they begin to build these routes, they start with the center line. Center line is just a center line of a road. Routes are built on top of center lines and use, when you build a route for a county, you'll have like one feature for the whole county. What I'm showing here is I've selected a little tiny portion of that road right there, and in these three tables up here, there's one center line piece which roughly goes from about there to there, and the routes are all the routes incorporate that center line. There's 4 routes there and one event, which is the through lane event I was talking about. To address that, what you need to, if you're going to look for gaps in that, you need to go back to the center line and get all the pieces of the center lines that participate in the route. It's not really a lot of fun, but you have to go back to the center line to figure out which route is dominant and then begin to look for gaps. This is the really awful SQL code that accomplishes what I had to do. A big part of it is just establishing all this junk here in the middle. That is just to figure out which route is dominant and which pieces that I have to worry about. Because for the non-dominant routes, there aren't events. So then I'm using common table events, which lets you essentially create a temp table within a query. I get my dominant route. Now I start to combine the tools. I buffer the center lines, and then I intersect the event with the buffer of the center line, and then I grab the difference between the two from the center line. And then I want to deal with it as individual line pieces. So it'll return multi-line strings. So if you've got a gap way over here and a gap way over there, it's returned to you as one record. I don't want like a little tiny piece over here, little tiny piece over there in one record. I want 2 records or 5 records, however many it is. So in SQL, they don't have a way to go from multi-part to single part directly. So I had to write some recursive SQL, which no one really likes recursion. I mean, it's a good thing, but it's really hard. It's awful, frankly. Recursion's terrible. But in PostGIS, there is a spatial function, which I really like because it's called stdump. And it will split up multi-part features to single-part features directly for you. At DOT, in addition to a convoluted data model, our IT architecture is convoluted, and I'm not allowed to create a stored procedure in the database because that would be modifying the schema of the database. So there's always different ways to accomplish what you have to accomplish. That's the same query, but written into a really long string to be executed from the C#. And it's parameterized so that from the UI, I've got a really small UI built where people can pick which event and which route class, and eventually which database instance they want to go from. So when you pick your event and your route class, this will go statewide and go through literally hundreds of thousands of records and spit it out for you within 10 minutes. There is a similar workflow directly in ArcMap to do this, but it takes hours or days to accomplish for the state. Right now, I'm just putting it out as a shapefile. I'm going through an intermediary step between going from the SQL output. The SQL output is returned to C#. C# turns it into an ArcAJAX object in-memory feature class. This is like an intermediary product. Eventually, we will go from that in-memory feature class directly back into SDE, but there's another awesome tool, Workflow Manager, that this code has to be incorporated into. Long story short, they needed something now that would let them find these gaps and address them, and this does it very quickly. We were able to get better than 95%. If I said it was a gap, it was I was accurate more than 95% of the time. I'd like to figure out exactly why there's like a very small amount of records that are not actually gaps, but with the data model, and there's tolerances within the database. So if something is within like some really small number of something else, as far as the database is concerned, it's the same thing. That's difficult for me to address in my queries. But at any rate, they were happy with more than 95%. I'm running out of time, which is good. I'm going to I'm going to hop over here to a web example. When I was at agriculture, we did a project in conjunction with soil science at NC State. They have a tool that they call the realistic yield expectation model. It was a multi-year effort between NC State, Department of Agriculture, and what it does is basically takes soil polygons. You pick a county, pick your soil. You can put in a representative slope value, and it'll spit out a table of on that soil for whichever crop you want to have, what your expectation would be if you amend your soil with this much nitrogen, this much phosphate, whatever. They'd been wanting a mapping tool for a bunch of years, and so I worked with them and built this map viewer. This is a mashup of a lot of different technology, including either the Google Maps API is in here, OpenStreetMap's in here. The red lines that you see there, that's a WMS that's produced by ArcGIS Server. The gray lines, which are a little fainter, are another WMS, also ArcGIS Server. There are over 5 million land records in North Carolina and over 1 million soil polygons. There's no good way to deliver all of that as vectors to the web. WMS is basically, it's serving up an image, which you can do fairly quickly. So if I click on parcel, what it does is it goes to the database and it grabs the polygon of that parcel. If I click on a soil, I grab the soil polygon. And there's a lot of scale dependency built into this. The soil polygons are pretty crazy. That polygon is probably made up of more than 10,000 points with donut holes. Let's go back here. So for this parcel, I've got a table that's in the database that from that parcel, by getting the latitude and longitude, I've already pre-calculated the soils that are on that parcel. And you can see there's just a little tiny sliver of that Baden Tara soil. Looking at this soil, the Georgeville, this is grabbing in the soil, it's an MU key. I grab the MU key, and then I can query the NC State realistic yield tool and tell you that if you want to grow barley, a realistic expectation would be 77 bushels on this soil. There should be, well, there's more to this table. I can't. I'm gonna do it this way. Yeah. So you got a link to this. Realistic yield of 77 bushels, you should expect to apply 113 pounds of nitrogen to that soil. At any rate, jump back here. So how's it doing it? jQuery provides AJAX, and make an AJAX call. When you click on a point on the map, I grab the latitude and longitude and send it off to through AJAX to this endpoint. It's a very simple ASMX file. It's just endpoint for a service, and within that service, I've got several methods: get parcel envelope, get points, get poly from lat long. I probably should have named them better, but I didn't. If I click on that get poly from lat long, it would pull up this interface where you can put in a lat long, which is just your latitude, comma, your longitude. Nothing special. And that service calls this stored procedure, where with the parameters of lat and long, I declare a geometry as a point. I apply the latitude and longitude that were passed from the AJAX call from the web, with 4326 is the SRID for WGS 84. And then I intersect with the spatial function ST intersects, and again, STI uppercase. I intersect the two. And then within the rest of that stored procedure parses it to Geo JSON. Geo JSON, the web is ready to consume JSON. It's built into browsers. It's been built into lots of JavaScript libraries. I didn't write the parsing to the Geo JSON. Google found it for me. Someone else already did that for me. I'm not going to reprogram something that works just fine. So, my understanding is this has been extended and other people are using it within the agency after I left. But at any rate, with PostGIS, they've got a spatial function, ST as GeoJSON, and you wouldn't have to go through that. You could just export it directly to GeoJSON. So how can you begin to use, how can you get started with SQL Spatial? Maybe you don't have SQL Server Studio installed on your computer. A lot of people don't. So you should join the OGC, right? It's only $500 to $55,000 to join. Write a check for them, you know. No, you don't have to do that. If you've got ArcGIS installed, I think it started in 10.3 maybe. When you add data, if you do it from the file menu and you go add data, you can add a query layer. Come on. When you begin the add query later, it will point to whatever SDE connections you have to your databases, and you can start to write a spatial query. And within that, so that query returned this line. Not terribly exciting, but hey, you wrote the whole query out yourself. You weren't using select by attributes. With that said, you can do a lot. You can write out more robust SQL queries. So here I'm modifying. You can begin to use left and right directly in your query. You can use the intersects functions. There's still some limitations. Yes or I still will only, if you're doing a join, they will only deal with one-to-one on a join. And the name I gave it for that query was fact check. If you hit the validate button, it will also, on the previous slide, there was another dialog there, which, can I go back to it? Yes, good. After you validate this, hit the next button. It's going to basically look at the fields that you're pulling back, and it is going to force you to select a unique identifier field. And there's the result. And it came with the name that I gave it in the wizard thing, which was fact check. So at this time, I'd like to give you all an opportunity to ask questions.
Have you used any of the ST geometry methods that create geometries? Like they do it for like a union or a dissolve or merge?
Yes. Yep. So you directly in the database, if you're in one of the I don't think you can do like an ad hoc geometry creation with that tool, but if you've got like a studio for dealing with SQL, you can declare a geometry, you can create it on the fly, you can grab the geometry from somewhere else, and then yes, you can definitely do those functions. If you grab your geometry here from an with that spatial query, if you grab an existing geometry from a table, yes, you can do ST union. Yeah. Yep.
Is there a good tool to convert sheet file to SQL spatial format?
Yes, directly in, you can do it directly in our catalog.
Oh, really?
Yep. Just import the data into a database. It doesn't, with SQL Server, the spatial data types are just built in there. When you build the database, you don't even have to tell it when you're building the database that it's going to be spatial. The spatial objects are just available, like because you installed it. And that's an interesting. If you're inside the database, you can have multiple geometry columns. So if you've got multiple geometries you want to associate with the same record, you could have 5, 6, 10, I don't know, a lot, however many spatial columns you want in the database, which is pretty cool.
And feel free to ask questions after. I think it'll be around
Yep.
after.
Yep.
You want to hang around, enjoy the other presentations?
Yep. There it is. Thank you for your time and attention.